Welcome everyone. Welcome back to our class. I'm Rochelle Mishra and I shall be dealing with our subject Pharmaceutical Inorganic Chemistry. See, today's lecture is again a continuation of our previous one in which we were discussing about emetics. Alright, like in our previous lecture we had discussed about emetics. Similarly, we will continue in our today's lecture. In our previous lecture, we understood about the drug copper sulphate. We had discussed about several aspects of emetics and we had understood chemical properties, physical properties. We have seen the preparations, or we have discussed about the preparation, assay and uses of copper sulphate. In our today's lecture, we will again be dealing with the same topic of emetics with respect to sodium potassium tartarate, with respect to the drug sodium potassium tartarate. Alright. So, before learning about this drug sodium potassium tartarate, it is essential to understand about emetics first. Alright. So, what are emetics? Again, a new terminology for everyone, for our newcomer students who are entering into pharmacy, a new terminology, a new terminology which we could say, emetics. What is this term? What is meant by this term emetics? Very simple. These are substances that induce vomiting. Very simple, layman term. If we try and remember, emetics are the substances that induce vomiting. Simple. Okay. Now we will learn this in detail. Emetics are agents that cause vomiting. Okay. Vomiting, what is meant by vomiting? It is the expulsion of gastric contents. Vomiting means expulsion of gastric contents. Okay. That is removal of gastric contents. There are two general classes of emetics. Emetics can be categorized into two general classes. Okay. The one class, it stimulates the CTZ, or also known as the chemoreceptor trigger zone, CTZ. One category of emetic, they stimulate the CTZ or the chemoreceptor trigger zone, and the second act on the stomach itself. First one CTZ, second one acting on the stomach. Acting on the stomach. The second acts on the stomach itself. Now, again, what is this vomiting? It is the expulsion of gastric contents. What is vomiting? Expulsion of gastric contents. Clear all of you? Now, what is nausea then? How do we differentiate between nausea and vomiting? All of you must have heard these two terminologies side by side. I mean, this is usually used along with each other. Am I right? Nausea and vomiting. So, what is meant by nausea and what is vomiting? Are these two same? Are these two similar things? Well, in today's class, I will explain to you the basic difference between the two. Well, nausea is the feeling to vomit. Okay. It is the sensation to remove out the gastric contents. Nausea is a queasy sensation which may or may not precede the expulsion. Clear all of you? Nausea is just the feeling. It is the queasy, uneasy feeling of trying to remove out the contents. But it may or may not lead to expulsion. Clear all of you? The cause of the vomiting must be identified. The cause must be identified in case of nausea. But vomiting is definite expulsion of the content. Clear? Nausea is just the feeling to expulse, whereas vomiting is compulsive expulsion of the contents. What are antiemetics? How does antiemetics help in vomiting? Well, antiemetics, they don't help much. They just help in masking the cause of the underlying condition. Okay, they just mask the actual cause for vomiting. But it is always essential, it is always important to understand what is causing this vomiting. Alright, so that treatment could be given. An antiemetic simply stops this expulsion or this removal. Alright, it doesn't cure the reason for this expulsion or the reason for this nauseatic feeling. Antiemetics can mask the underlying cause of vomiting and should not be used until the cause has been determined. Until and unless you know the reason for emesis, antiemetics should not be given or it should be prevented. Unless the vomiting is so severe as to cause dehydration and electrolyte imbalance. Clear all of you? Antiemetics should be given only in the case where you know the cause for emesis or the cause for vomiting sensation. If you don't know the cause, then we better avoid and try and understand the cause first. Okay. So, but in several cases, in certain cases where the vomiting leads to severe dehydration and electrolyte imbalance, in such cases antiemetics can be given. Antiemetics can be given. Now, what are the causes for vomiting? That we can understand via this one figure. Via this one figure, we shall try and understand the cause for vomiting. The first cause is stimulating the stomach. The first cause is direct stimulation of the stomach, alright. Whereas the second, which is the vomiting center, stimulation of the vomiting center. Stimulation of the vomiting center, okay. How is this vomiting center stimulated? When is this vomiting center stimulated? See, this vomiting center is stimulated due to presence of odor, smell, taste, okay. Unlikable odor, smell and taste. They trigger the vomiting center. They trigger the vomiting center. Hence, there is a compulsive need to expulse out. Hence, there is a compulsive need to remove out the contents in the gastric layer. Next, the other reason is stimulation of chemoreceptor trigger zone or the CTZ. Chemoreceptor trigger zone. This is the second reason for vomiting. What happens? What are the substances which could likely stimulate this reason is drugs or toxins. These have the ability to reach the chemoreceptor trigger zone. This CTZ further sends signal towards the vestibular center. Towards the vestibular center. This vestibular center sends signal towards our diaphragm. Towards our diaphragm. So that there is a constriction of the diaphragm. There is a signal towards our gastric cavity. There is a constriction of the gastric cavity. So, all this together leads to expulsion or the peristalsis of the material present in our stomach. So, basically in the brain, two areas are stimulated. The first one is vomiting center and the second one is chemoreceptor trigger zone. This chemoreceptor trigger zone is stimulated by drugs and toxins. It can be stimulated or it can be reached by drugs and toxins, whereas the vomiting center in turn is stimulated by bad odor, bad taste, unlikely cellular debris, such things or fumes, such things leads to triggering of vomiting center. Clear all of you? Now, the chemoreceptor trigger zone, it is an area of the medulla oblongata. It is an area of the medulla oblongata that receives inputs from the blood-borne drugs. Alright, the chemoreceptor trigger zone is an area of the medulla oblongata that receives input. As we have seen, it is the area of the medulla oblongata that receives input from drugs and toxins, that receive input from blood-borne drugs or hormones. They communicate with other structures in the vomiting center. They communicate with other structure in the vomiting center and vestibular center to stimulate vomiting. So this is about chemoreceptor trigger zone. This CTZ or the chemoreceptor trigger zone is located within the area postrema, which is on the floor of the fourth ventricle and is outside of the blood-brain barrier. Okay. Emetics such as syrup of ipecac have been used in emergent cases of poisoning because they induce forceful emptying of the stomach. Okay. So, forceful emptying of the stomach is stimulated by emetics such as ipecac. Now, apart from inducing vomiting through the chemoreceptor trigger zone, stimulation of gastric reflex or stimulation of the gastric layer also leads to vomiting. Now, what is this stimulus that affects the CTZ or the chemoreceptor trigger zone? See, tactile stimulation of the back of the throat. Okay, stimulation of the back of the throat causes a reflex to get rid of something that is too big or too irritating to be swallowed. Okay, this is one of the reasons. This is one of the reasons that leads to vomiting. Okay, or that leads to stimulation of CTZ. Tactile stimulation of the back of the throat by any big substance which is difficult to swallow. The second reason for vomiting to be caused is excessive stomach distension. Excessive stomach distension also leads to vomiting. It also causes vomiting. Increasing intracranial pressure. Increasing intracranial pressure by direct stimulation is another cause for vomiting. Stimulation of the vestibular receptors in the inner ear causes intense pain fiber stimulation. This further leads to vomiting. So these are the cause or these are the stimulus for the CTZ to respond and cause the reflexive action that leads to vomiting. Clear all of you? Now, other reasons include direct stimulation by various chemicals. Direct stimulation by various chemicals, including fumes, certain drugs and debris from cellular death also causes our vomiting. It also leads to vomiting. Clear all of you? Direct stimulation of the CTZ, direct stimulation of the chemoreceptor trigger zone by various chemicals including fumes, certain drugs and debris from cellular death may also lead to vomiting. CTZ is stimulated by several different processes. Your chemoreceptor trigger zone is stimulated by several different processes. What are they? These processes also initiate a complex series of response that first prepare the system for vomiting and then it causes a strong backward peristalsis to get rid of the stomach contents. Alright, so this is what happens in case of an emetic, when an emetic is given or in case when vomiting is caused. Now, in this slide, we shall discuss about different neurotransmitters that causes vomiting. Okay, acetylcholine, it is a muscarinic receptor. This acetylcholine is responsible for gastric constriction. Muscarinic receptors are responsible for gastric constrictions. They are responsible for bronchial constrictions. They are responsible for bronchial constrictions. They are responsible to cause micturition. Okay. So these are the neurotransmitters. For example, acetylcholine. Acetylcholine acts on the muscarinic receptor. This muscarinic receptor is responsible for gastric constriction, bronchial constriction and micturition. Clear all of you? Now, apart from acetylcholine, there is another substance known as substance P. This substance P is a major ligand for NK1 receptors. This substance P is a major ligand for NK1 receptors. These NK1 receptors are a family of peptides. They all act on the emetic center. Clear all of you? The CTZ is also stimulated by dopamine. The CTZ or the chemoreceptor trigger zone is also stimulated by dopamine. This dopamine acts on the D2 receptors. Apart from acetylcholine, apart from substance P, apart from dopamine, there are other neurotransmitters that act on the emetic center. What are they? Alpha-2 adrenergic drugs. They act on the NE receptors. Serotonin is another neurotransmitter that act on 5-HT3 receptors. See, these are very important. These are the neurotransmitters. These are the hormones which affect the vomiting center or which affect the emetic center. Alright. Now, acetylcholine acts on M1 receptors, enkephalins and histamines. They act on H1 and H2 receptors. Okay. So, here we have seen a list of those neurotransmitters that affect the emetic center. These are the list of those neurotransmitters that affect the emetic center. Other neurotransmitters can be briefed into alpha adrenergic receptors in the chemoreceptor trigger zone are important in inducing emesis, especially in cats. Okay. So, alpha-2 adrenergic agonists would help in inducing emesis. Example of these alpha-2 adrenergic agonists is xylazine. It is xylazine. They are more potent emetics. Okay. Especially they are used in cats. Rather than canines, they are more potent in cats. 5-HT1A antagonist can act as an anti-emetic agent. Example, buspirone. Similarly, alpha-2 adrenergic antagonists, example, acetylpromazine, yohimbine, mirtazapines, they suppress vomiting in cats. Now, what are the adverse effects of emetics? Well, see, before prescribing emetics to anyone, a lot of things has to be kept under consideration. Okay, a lot of detail has to be taken from the patients in terms of emetics are contraindicated. Emetics should not be given in patients that are hypoxic. Alright, that means they do not get sufficient oxygen. Dyspneic, such patients, emetics should not be given. The patients who are unable to swallow, emetics should not be given. Hypovolemic people or hypovolemic patients should not be given an emetic. What is meant by hypovolemia? Hypovolemia is a condition in which body loses 20% of its fluid. Okay. So, in those patients, emetics should not be given because this would further aggravate fluid loss. Emetics should not be given to animals which have ingested strong acids or alkalis, because these strong acids or alkalis contents of the vomitus may damage the tissue of the esophagus, pharyngeal tissues and oral tissues as well. Given the risk of aspiration, emetics should not be given after ingestion of petrolatum or related compounds, because the risk of subsequent aspiration overweighs the potential toxicity. Okay, the syrup is clear with a mild odor. I mean, the emetic syrups are generally clear. They have unpleasant taste. Now, here we will be seeing classification of emetics. Here we shall see the classification of emetics. Emetics are classified into stimulants of chemoreceptor trigger zone. Example, apomorphine and morphine. They are stimulants of the chemoreceptor trigger zone. Example, apomorphine and morphine. The second category, irritants of gastric mucosa. That is, they cause irritation to the mucosal membrane of the gastric layer. Example, mustard and sodium chloride. Next, the third category is a combination of both. That is, they act as chemoreceptor trigger zone stimulant and gastric irritant as well. Okay, so the third category has the mechanism of action which is a combination of both. They cause gastric irritation and cause irritating and cause stimulant effect, CTZ stimulant effect as well. For example, ipecacuanha and digitalis, ipecacuanha and digitalis. Clear all of you? Now moving on further, we shall be looking into the drug in detail, which is sodium potassium tartarate. This sodium potassium tartarate belongs to the category of emetics. They belong to the category of emetics. Sodium potassium tartarate is a double salt of tartaric acid. It is a double salt of tartaric acid. It has got a chemical formula of C4H4O6 potassium K sodium Na, okay, dot 4H2O, dot 4H2O. It is also known as Rochelle's salt or potassium sodium tartarate. These are the synonyms of sodium potassium tartarate. It is also known as Rochelle's salt or potassium sodium tartarate. It is a colorless to white crystalline powder with a cool and saline taste. It has got a cool and saline taste. Here we can see the structure of sodium potassium tartarate. How is this sodium potassium tartarate synthesized? Well, the chemical reaction involved in the preparation of Rochelle's salt is the conversion of sodium bicarbonate to sodium carbonate. Clear all of you? Sodium bicarbonate, NaHCO3, is converted into sodium carbonate, Na2CO3. This involves release of carbon dioxide and water. CO2 and water is released out. Okay. Potassium bitartarate. In the next step, potassium bitartarate reacts with this formed sodium carbonate to form our sodium potassium tartarate. Okay, dot 4H2O. This is also known as Rochelle's salt. So a two-step process. Sodium bicarbonate decomposes into sodium carbonate, carbon dioxide and water. This sodium carbonate reacts with potassium bitartarate, also known as cream of tartar, to form sodium potassium tartarate. It has a molecular weight of 282.1 gram per mole. It has a density of 1.79 gram per centimeter cube. It has a boiling point of 220 degrees Celsius and melting point of 75 degrees Celsius. Now looking into uses of sodium potassium tartarate. Well, sodium potassium tartarate is used as a laxative. It is used as an emetic. Okay. These are the pharmaceutical uses. What are the other uses? It is used as in the silvering of mirror. It is used in the silvering of mirror. It is one of the ingredients in Fehling's solution. Okay, these are other uses, non-pharmaceutical uses. Used in the silvering of mirror. It is used as one of the ingredients in Fehling's solution. It is used in the electroplating process. It is used in cigarette paper. It is used to break up emulsions. It is one of the ingredients in Biuret's reagent as well for protein determination. Failing solution, carbohydrate determination, Biuret's reagent, protein determination. It also helps to maintain the alkaline pH. It is used as a common precipitant in protein crystallography as well. So these were the major uses of sodium potassium tartarate, also known as Rochelle's salt. I hope the class was helpful to you all. With this, we end up our topic of emetics. Thank you.